All right, today we're going to learn how to simplify, multiply, and divide rational expressions. A rational expression is in simplified form provided its numerator and denominator have no common factors other than 1. To review from early in the year, rational numbers could be written as fractions, so rational expressions are all going to look like fractions. So, to simplify rational expressions, we must divide out all common factors. If we're going to divide out common factors, the first step is to factor. If your factoring's not the greatest, you may want to go back and re-watch some of the factoring videos. As we go on in this lesson and this unit, there's going to be a lot of factoring involved. Also, since we cannot divide by 0, we must state the domain restrictions. And we did that a little bit when we did compositions of functions. All right, so if possible, simplify the rational expression. So step 1 is always going to be to factor. The factors of x squared minus 81, since that's a difference of perfect squares, it'll be x minus 9 and x plus 9 over. On the denominator, all we can do is factor out a common factor of 2, and we'll be left with x minus 9. Before we do anything else, we're going to state our domain restrictions. We're going to say x such that x cannot equal, and we're just looking at the denominator. Since the 2 out here does not have an x with it, we can ignore it. And then the number that's going to make x minus 9 equal to 0 would be 9. Then we're going to cancel any factor that is on top and bottom. So the factors of x minus 9 can both cancel out, and we'll be left with x plus 9 over 2. All right, another example. Step 1 still is to factor. The factors of x squared plus 5x plus 6 are x plus 3 and x plus 2, because 3 times 2 equals 6 and 3 plus 2 equals 5. On the bottom, we're going to factor out a GCF. They have an x squared in common, and we'll be left with x plus 3. Then we state our domain restrictions, x such that x cannot equal. The number that are going to make this parentheses 0 would be a negative 3. And then because of this x squared out here, what squared give us 0? That would be 0. Now we can cancel common factors, which would be the x plus 3's. And we're left with x plus 2 over x squared. Now many people would want to say, oh, there's an x here and an x here, we can cancel those out. You can't because of this plus sign up here. If the x is being added or subtracted to any other numbers, it can't cancel with a single x on the bottom. So that'll be our final answer. All right, now we're going to move on to multiplying. To multiply fractions, you're going to first factor, then you're going to do the domain, then you're going to cancel factors that match, and then we're going to simplify. All right, so let's start by factoring all 4 pieces, both numerators and both denominators of these 2 fractions that are being multiplied. The first numerator just has a common factor of x to factor out. The first denominator factors to x plus 1 times x plus 1. And that's going to get multiplied with this factors to x plus 3 and x plus 1. And then we have a common factor of x times x plus 3. Then we're going to state our domain. X cannot equal, from here, negative 1. This single x will give us a 0, and the x plus 3 means x cannot equal negative 3. I'm not too worried about the order that you write the domain. A lot of times if it's on the multiple choice, on the iTest or the SOL or something, they'll probably put it in order from smallest to greatest, but I'm not that worried about that, as long as all three numbers are there. All right, so now we're going to cancel common factors. We've got an x up here and an x down here. The factors don't have to be in the same fraction to cancel, but one does have to be in the numerator and the other has to be in the denominator. So the x plus 3's can cancel, and this x plus 1 up here can cancel with one of these. They have to cancel in a pair. You can't cancel in a triple. So what we're left with, the only thing in the numerator is x minus 2. And in the denominator, we're left with x plus 1. That's our final answer. In number 4, a lot of times students look at this and say there's nothing to factor. And they think that 12 minus x is the same thing as x minus 12. Well, would it be the same thing if you had $12 and had to pay 100 as if you had 100 and only had to pay 12? No, those are pretty different things, but there's a way that we can make them the same thing. Here the x is negative. Here the x is positive. Here 12 is positive. Here 12 is negative. The only thing different about them is their signs. So what we're going to do with this top one up here is we're going to factor out a negative. If we take out the negative, that makes the x positive, and that changes the positive 12 to a negative 12. Now we can state our domain, x, such that x does not equal 12. And now let's cancel our factors. 3's gone, 3's gone, x minus 12, x minus 12. All we're left with is a negative, and if everything cancels, it's considered a negative 1. All right, let's move on to division. To divide fractions, again, first step, factor. Second step, domain. Third step, change to multiplication and flip the second fraction. Step 4, we're going to have to do the domain again, and then step 5 is finally to cancel. All right, so let's get started factoring. X squared, just x squared. X squared minus 1 factors to x minus 1. And x plus 1, because it's the difference of perfect squares, divided by 3x over x plus 1. There's nothing to factor with those. So for our domain, we're going to say that x cannot equal, can't be positive 1 because of this factor, and it can't be negative 1 because of these two factors. So I'm just going to write it as plus or minus 1. If you want to write them separately, that's fine. You can do that. Then we need to divide our fractions with, if you remember from elementary school, when you divide fractions, you keep the first one the same. You change the division to multiplication, and then you flip the second fraction. They might have told it to you as same change flip, something along those lines. All right, because we flipped this second fraction, we now have a new thing in the denominator. And what's going to make this denominator 0? That would be 0. So now we're done with our domain. Now we can cancel our matching factors, x plus 1, x plus 1. And then a lot of times people don't notice that this and this have something in common. X squared is the same as x times x. 3x is the same as 3 times x. So technically, these both have a factor of x that can cancel out. So in the numerator, we're left with just this x, and in the denominator, we're left with a 3 and an x minus 1. So our final answer is x over 3 times x minus 1. You can distribute the 3 back in if you'd like to, but it's not necessary. We're going to leave our answers in factored form. All right, let's move on to number 7. The factors of 3x squared plus 13x plus 4 are 3x plus 1 and x plus 4. Again, if you're having trouble with your factoring, go back and watch those videos. X squared minus 4 factors to x minus 2 and x plus 2. In our numerator here, we have a common factor of 4. And our denominator is just going to stay. So our domain restrictions so far, x such that x cannot equal, based on those, plus or minus 2. Then we're going to rewrite our first fraction. Change to multiplication. Flip our second fraction. Because of our new denominator, we need to add that x cannot equal negative 4. And now let's cancel. X plus 4, x plus 4, x plus 2, x plus 2, and we're left with 3x plus 1 over 4 times x minus 2. These problems look like a lot of work, but once we get through the factoring, factoring's typically the hardest part. It's just a lot of canceling and then being able to read what you canceled and what stayed. It gets pretty easy after that. All right, one big challenge problem. So we got a lot of factoring to do with this one. Our first fraction doesn't look like a fraction, but we know that anything can be put over 1. This is going to factor to x plus 6 and x minus 5. Keep that over 1. Then we're going to divide by x minus 6 and x minus 5 over x plus 3 and x plus 4 times x minus 6 and x plus 6. So far in our domain restrictions, x cannot equal negative, forgot the such that. X cannot equal negative 3, negative 4, or negative 6. So we're going to keep our first fraction the same. We're going to switch to multiplication. We're going to flip this fraction. Because this one's being multiplied, it'll stay multiplication, and it will stay right side up. If we needed to flip the second fraction, there would have been parentheses here at the beginning saying we're dividing by this whole thing. All right, now we can cancel our factors that are on top and bottom. Remember, they don't have to come from the same fraction. So x minus 5, x minus 5, x minus 6, x minus 6, x plus 6, x plus 6, and the only things we're left with are x plus 3 and x plus 4. So like I said, factoring's the hardest part of these problems. If you're having trouble with factoring, make sure you go back and watch your videos. Thanks for watching. See you in class.